So, welcome to the 6th year physics August seminar. I've given you a set of notes. On light and sound. Light and sound is a very big section of the course. Altogether I broke the course down into 5 sections: light and sound, electricity, mechanics, heat, and modern physics, and I include the particle physics in that. So light and sound is a major part of the course. So you've got those set of notes. And I'm going to explain to the seminar how you use those notes. And I'm going to do a number of topics from chapter 4 in those notes. Really important topics, they ask them a lot: interference and diffraction. There's a formula that we use quite a lot called n lambda is equal to d sine theta. You're going to have to prove that formula. What do I say about physics? Physics is not hard. Mathematically, it's not particularly difficult. All you're doing is simple, I would say harder junior cert maths, nothing more than that. So it's actually very, very straightforward. You have to be able to use your calculator, put scientific notation into your calculator. The problem I find with physics is it's busy. It's full of so many parts. It's a very, very long course. Now, there's certain parts of it you can leave out, but they tend to mix questions around more recently. So there's still a lot of the course you need to do. You probably have to get 80% plus of the course done to get your H1. It's a very busy course. You have to be very, very well organized. The thing I do with the notes that I give you, the least I can do for you is to give you a set of notes that organizes you everything you need. Leaving cert questions are in the notes, solutions, the whole lot. So how you organize yourself is in the notes. Everything you need, everything you require there. It's not that difficult, but you're not going to get lots of people getting H1s because the amount of work required, there is a lot of work required. Mathematically, as I say, not enormously difficult. You'll get the idea anyway. The kind of stuff that I'm doing involving interference and diffraction, that's really as hard as it gets. If you can understand what's going on there, then it is possible for anyone to get a H1. I do say when I look at a class, I say everyone here can get a H1. I don't say that when I teach maths, and I don't say that when I teach applied maths, but I say it in physics. But it does require a huge amount of work to get to that point. So the notes will organize you. So look, I hope you enjoy the seminar and I hope you get something from it. So sit back and enjoy. I want you to go to these notes, your final revision guide. That guide is a nice little pack. That guide contains a summary of everything you need to know for your Leaving Cert Physics course. It's like your little Bible. All your definitions, all of your experiments, all of the methods and techniques that you need to use are contained in that revision guide. So I'll be referring to that revision guide throughout our course. So you've got in front of you, amongst many notes, you've got your final revision guide. Let me go to the second page in that guide. We're going to page 2. Now I'm going to give you a breakdown of the paper. It's very hard to know how to start revising if you don't know what you're revising for. So this would be a breakdown of the entire physics paper, the kind of techniques that you're going to employ, and so on. Well, let's start. There's 400 marks altogether with your physics paper, and 3 hours is the length of time you have to do the paper. 3 hours, I think, is sufficient. I never really hear too much about students running out of time, so if you manage your time well, 3 hours is absolutely fine. But I will be talking about how long you should spend on each question as I go through this. Well, there are 2 sections. You've got section A and you've got section B. In this particular lesson, I'm going to talk about section A. Section A is the experimental section. And there are 120 marks for that. The theory section, section B, we've got 280 marks. So we're talking about 30% of the marks are going to the experiments. I could say they're mutually exclusive. So in other words, one section
doesn't affect the other section. So you know you're told when you go into an exam to read the entire exam paper. I wouldn't do that in this case. I would go straight to section A. I wouldn't even look at section B. I would suggest that section A is far easier than section B. It's far easier to study for it. The time I'm going to devote to section A would be 1 hour. I would start with section A. I wouldn't look at section B at this stage. I would try and build up my confidence. We're all a bit nervous going into an exam. We're very eager to find out what questions are being asked. But I would say forget about section B, just start with section A. So section A is the experimental section. 120 marks. How long will I spend on that section? I would say a maximum of 1 hour. What is the content for that section? Well, there's a list of experiments. And that list of experiments in my notes, I want you to turn to page 10. So in page 10, I have a list of experiments. You know, this is what we call the mandatory experiments, the ones that you do in the lab. You know, if you've done them in the lab, you already know a huge amount about them. So when they ask you questions like, how did you find the mass of ice? You're just going to use your cop on, your common sense a lot of the time. So you already know a lot of physics before you go into the exam, simply by being in the lab for 2 years, being in the classroom for 2 years. How many experiments are there altogether? Well, I've listed them, and I've used a code to list them. So you've got mechanics, M1 to M8. Now, if you're doing the higher level, they won't ask you to do M1 or M2, whereas M1 and M2 might be incorporation to M3 and M4. So I'm really talking about, when I do this, I'm really talking about doing the experiments from M3 to M8. What about heat? There's 4 heat experiments, H1 to H4. The first 2, they don't seem to ask. I think they asked H2, which is the SHC of a liquid or a solid. They asked that once in 2007. But they hardly ever ask it. The reason may be that in the syllabus it says, find the SHC of a solid or a liquid. So they're afraid if they ask you a solid, people who did the liquid will complain. So I suggest that the only experiments that they're going to ask here really are H3 and H4, which are the specific latent heat experiments. Sound, 3 experiments, they'll ask them all. Light, well, you've got 5 experiments on light on page 10, and that middle one, L3, they usually only ask on the ordinary level. So you're talking about doing L1, L2, L4, and L5. And then the electricity, yes, they'll ask the electricity, E1 to E5. So overall, what am I actually talking about? I'm talking about doing 6 and 2 is 8, and 3 is 11, and 4 is 15, and 5 is 20. We're talking about altogether you having to study 20 experiments. That's not a big deal. Now I'll explain as I go along in this lesson how you prepare for those 20 experiments. You know, when you open up your book, an experimental book, and you see the experiment and you've got the method that might go 1, 2, 3, 4, 5 all the way down to 10. Well, you will not have to write out the method in the exam. So what you have to learn about the experiments in order to do section A is actually quite a small amount of content. So I'll go through that with you in detail throughout this lesson. Right, let's get back to our paper now. So we have 20 mandatory experiments to learn. I open up my exam paper. I don't go near section A. I don't go near section B, should I say. I go to section A and I have 4 questions. The first 4 questions are about the mandatory experiments. you have to do 3 out of 4 experiments. Question 1 appears to be, I'm not saying this is written in stone because it may change, but I'm pretty certain of it. Question 1 is always a mechanics experiment. Has been since this course started. Now this course started quite a long time ago. It started in 2002. So we're going from 2002 to 2019. So you've got say 20 years of questions. Question 1 is always mechanics, and question 4 is always on electricity, which I call E. Then what about the rest? Well, the rest are a combination of your sound, S, your heat, H, and your light, L. So does that mean I should specialize? So for example, I could say to myself, well, I'd be safe enough to leave out let's say all the electricity experiments and then do the rest. Well, my view on it is you should do all 20 experiments. The choice isn't fantastic. It's 3 out of 4, and sometimes you may get a dodgy question. So what do I mean by a dodgy question? Well, they should ask the questions very generally, but schools do experiments in different ways, and they might ask a technique that's not quite your way, even though they shouldn't. But there's no point in complaining about it afterwards once it's done. So I would suggest you do all 20 experiments, and that will take the stress out of it. Now you have your full choice. So we're talking about doing 3 out of 4 experiments. How long should I spend? Well, if I'm talking about a maximum of 1 hour, you're talking about doing 20 minutes per question. I think that's plenty. You know, most students probably get them done in 12 to 15 minutes. 20 minutes per question. Look, be very strict about your timing. The worst thing, as you know, in any exam is to leave out half a question. So when I do my first question, I spend 20 minutes. When 20 minutes is up, move on, move on. If you have time at the end, go back, but do not leave out. Do not be in such a position where you're going to leave out half a question. That's a disaster. So you've got 3 20s, will give me the 1 hour. If I get them finished after about 45 minutes, don't say to yourself, oh great, I still have 15 minutes left of my hour, so I'm going to do a 4th question. Do not do that. If you're finished the 3 questions after 45 minutes, move on, of course. If you have time at the very end, then you go back and do that extra question. And of course, they will give you the marks for the best 3 questions out of 4. So that's the timing for my experiments. Now, how do I study for those experiments? Well, I've summarized the experiments. So inside your revision pack, you have a summary of every part of the course. I'll go through the different parts of the course later on. But if we go to page 11, you've got summary number 1, which is on light and sound. And towards the end of that, I have a summary of all the experiments. So if we go to page 31, I've laid out here all of the experiments and a summary of them. Notice I haven't written out a method. You know, when you study for an experiment, you just read the method. You don't have to learn the method. You certainly do not have to write out the method in the exam. Let me now talk about how do I study for my 20 experiments. It's actually not too difficult, and you can do this quite quickly. I've done the summary for you, but I find a lot of students prefer to do their own summaries because the way I do it might be slightly different to the way you do it with your teacher, so you might like to do a more familiar method. But this is how I study for the experiments. So I'm just going to go over to this board here on the left. I tell students to get a flashcard, a little index card, and on that flashcard, summarize everything you need to know about a particular experiment. So you're going to have 20 flashcards altogether. That's not too difficult to learn, 20 flashcards. because I'm just going to put in the essential information. What I need about every experiment, I need a labeled diagram. That's usually the opening part of every experimental question. Draw a labeled diagram of the apparatus used. So have a labeled diagram of all 20 experiments. That's easy learning. Just practice drawing, drawing, drawing. I've done that for you. I've got the labeled diagrams given inside the notes, so they are there for you. But as I said, you might want to actually tailor it for your own needs, your own experiment or whatever. I think it's a good learning experience anyway, just to do your flashcards and do your own summaries. Just by doing that, there's a huge amount of learning rather than just taking my stuff and looking at it. That's the first thing I need. The next thing I need is, every experiment, you'll have to do a graph. I'd say about half of them have graphs, or you're going to have to do some kind of mathematical calculation. So they'll always use something called a suitable graph. I mean, take, for example, one of the experiments. One of the experiments that I talked about earlier was a sound experiment. And S3 is a sonometer experiment. We're actually going to do that later in this revision course. And you've got a set of results of frequency and tension. Frequency in hertz and tension in newtons. They'll give you a series of results and they'll ask you to draw a suitable graph. That word suitable is very, very important. You have to know what that suitable graph is. What you have to know is, when you draw the graph, what quantity goes on your x-axis and what quantity goes on your y-axis. Well, in this particular example, tension will go on the bottom, but it's actually going to be the square root of tension, root t, and frequency will go along the side. And then when I draw that graph, I will get a straight line graph going through the origin. Now we'll talk about that later on. But you see, if I didn't know that when I went into the exam, if I didn't know it was f against root t, we also have to put in the units, of course, but I'll be doing all that later on. I'm just trying to make a different point here. If I didn't know it was the square root of t, and I drew a graph of f against t, well, that's a great way to lose loads of marks instantly. So I have to know, when they give me the results, they say draw a suitable graph, I have to get the square root of that, and then draw a graph of f against root t, and I get my straight line going through the origin. So inside your summary, you're going to have a sketch of the graph. You're going to put in the quantities that go on each axis. And you're going to do that for all the graphs that you have for the various experimental sections. Or you may have a formula. For example, a heat experiment uses a formula. So, or you're going to write down your formula. It might be, for example, E equals mc delta theta, if you're talking about heat. And that formula will be in your table book. So write down where it is in your table book, so you know exactly when you go into the exam where to go in your table book. Because your table book can be complicated. We'll talk more about the table book later in the course. So, I need to know my label diagram. I need to know if it's a graph, what is the graph, what does the graph look like, and know what the shape of it is. I mean, it's a great comfort, isn't it? When I draw my graph, I know it's going to be a straight line going through the origin, and when I draw it, that's exactly what it is. Now I know I've done it 100% correctly. Or a formula. What's the last thing I need? The last thing I need is something called some experimental details. Just little things about the experiment. For example, How did you find the mass of ice? You didn't throw the ice onto the weighing scales and let it melt all over the lab. No, you melted the ice in a calorimeter of water. Then you found the mass of everything at the end of the experiment, and by subtraction, you found the mass of ice. So various experimental details. They're also called errors and precautions. Precautions. What should I do to make the experiment better? What should I do to get a better result? That's what we're talking about, errors and precautions. Errors, what can go wrong with the experiment? Well, heat might escape, giving me a poorer result. How many experimental details do I need? I would say about 3 experimental details. So, in my summaries, I've written down a number of very important sources of error and precautions called experimental details. What else do I need to do to study for my experiments? Well, you know, here's a great way to start. Just get your 20 experiments, draw up your flashcards. That's easy work. So that's the first thing I would do. What else do I need to do? Well, after that, I would suggest the following. The methods for those experiments are written out in your books. I would just read the method a number of times just to familiarize yourself with the experiment. Look, if you've done the experiment already in the lab, you'll actually know a huge amount of stuff. So read the experiment. And then what else will I do to practice? Well, after that, it's just a question of doing leaving cert questions. Let me talk about those leaving cert questions. Let's go to another set of notes that you have in front of you. You have your notes on light and sound. So let's go to the notes on light and sound. And I'm going to go up to the end of chapter 5. And all the leaving cert questions on light and sound, I've written out. All the questions are there from last year's paper, 2019, all the way back to 2002 when the course started. And I've categorized them for you. So for example, I've written down there, chapter 3, refraction. There's all the leaving cert experiments, L2, Snell's law, L4, the focal length of the lens. So for example, one of the questions for Snell's law from 2010 is on page 97. So go to page 97 in your notes. I've laid out every leaving cert question like that. That's the way they do the maths. But we don't do that in the physics. The physics is just a straightforward paper where you write down your answers on your own exam script. But here's a lovely way to organize yourself. So I've got every single leaving cert question like this with gaps. So you can fill the answers in there. The graph paper is also provided. So everything is beautifully self-contained and organized for you. So basically, if you work your way through these questions, then you've done more than enough revision. And if you get stuck with anything, you have another pack of solutions, light and sound solutions. And every one of these solutions are in that pack. So you have a great way to study now. So just to summarize about the experimental section. You're going to do section A, the experimental section. It's the first thing you do when you go into the exam. You're going to spend a max of 1 hour on it. You're going to spend 20 minutes per question maximum. You have 20 experiments altogether to learn. I would suggest that we do all 20 experiments. That takes the stress out of it, doesn't it? You're not going in there hoping for a particular question. You don't care. You're going in lovely and relaxed. This is the easier section compared to section B. You're nervous going to the exam. This will build up your confidence. I'm not even looking at section B at this stage. And then in terms of studying for the exam, for this section A part of the exam, I'm going to put together my flashcards. The amount of stuff you have to do, I would say, is not enormous. Label diagram, what kind of graph or what formula, and 3 or 4 experimental details called errors and precautions. Read the method a few times, but don't learn it. Don't learn off the method 1, 2, 3, 4. Just read it, familiarise yourself with it, and then do leaving cert questions. And that will set you up nicely now for the rest of the paper.